In today's video, we will be exploring the next stage of scientific discovery, a discovery by CERN which shook the scientist to a great level. The physicists are eagerly anticipating the surprises it may unveil, from breakthroughs in understating the magnetic field of Earth to the remarkable discoveries that are yet to come. Get ready to dig through this remarkable journey of the world of modern physics. The Large Hadron Collider, built by the European Organization for Nuclear Research (CERN, is the largest and highest energy particle collider in the world. In 2008, after an excruciating long building period, the Large Hadron Collider (LHC) went operational. The Large Hadron Collider is an energy particle accelerator built by CERN. Ever since its formation, scientists have been trying to unravel the mysteries of the universe and are doing an incredulous job in it. However, recently, a scientist from CERN detected something marvelous and alarming during the operation of LHC, when the energy beam was increased. And ever since the incident, the scientists are trying to figure out a hypothesis to prove the process. The LHC is a particle accelerator built up by CERN between 1998 and 2008, consisting of a 27-kilometer tunnel located 175 meters beneath the France-Switzerland border. The first ever collision of this collider was achieved in 2010 at an energy of 3.5 tera-electron-volts per beam. The collider consists of 4 crossing points where the accelerated particles collide, and each of the 7 detectors is positioned around the crossing points and is designed to detect different phenomena. The collider primarily collides with proton beams that can also accelerate heavy beams of ions. The lead-lead collision and proton-lead collision are typically performed annually. The main purpose of this collider is to allow physicists to test predictions of particle physics theories, measure the properties of the Higgs boson, and search for new particles as predicted by supersymmetric theories. The term hadron refers to subatomic particles made of quarks, held together by strong forces with the same phenomena as atoms and molecules are held together by electromagnetic forces. The hadrons, including both brains, neutrons and protons, and mesons, pion and kaon, were discovered during cosmic ray experiments in the late 1940s to early 1950s. Its main purpose is to test the predictions of various particle physics theories, particularly measuring properties of the Higgs boson and searching for the large family of new particles predicted by supersymmetric theories. A collider is a kind of particle accelerator that brings to opposite beams together so the particles can collide. They may be difficult to construct, but based off on the principles of particle physics, the collider can be proved as an incredible research tool, as they reach a higher center of mass energy than fixed target setups. The scientist then analyzes the information and provides us with information about the subatomic level and laws of nature. A bunch of the byproducts that are produced only by high-energy collision gets destroyed after a short span of time, so it is impossible to study those. A tunnel with a width of 3.8 meters and lined with concrete was built between 1983 and 1988. The tunnel in the mountain was used to avoid the need to excavate a vertical access to the shaft and to avoid spending money on purchasing the expensive land. The tunnel also provided shielding against background radiation. The Large Hadron Collider is one of the world's most expensive scientific instruments ever, with a budget of 7.5 million euros. The initial testing of LHC was delayed for 14 months, when a magnet quench incident caused excessive damage to more than 50 superconducting magnets. In 2010 to 2013, the LHC collided with opposite beams to investigate the existence of Higgs boson. Scientists at CERN speculated that LHC would produce several Higgs boson to allow the physicist to either approve or disapprove of the theory. The first operational run lasted between 2009 and 2013, with a long shutdown till 2015 for the upgrades of the Large Hadron Collider. The second operational run occurred between 2015 and 2018, but was again shut down for upgrades till 2022. The third operational run in 2022 occurred with a maximum beam energy of 6.8 TeV during this trial on July 7th. A crack in the Earth's magnetic field remained open for 14 hours, enabling solar winds to penetrate through the opening and ending up resulting in geomagnetic storms and creating stunning auroras. Science fiction lovers were pretty excited relating to the crack, as some said that a monstrous villain might have been created through this crack. Despite all the theories, the auroras are such a mesmerizing sight that people find unable to take their eyes off of it. The crack in the magnetic field was created due to a phenomenon called co-rotating interactions from the Sun, or CERNs. These CERNs, large-scale plasma structures, are generated in the low and middle latitude regions of the heliosphere, where solar wind streams interact. The regions, like coronal mass ejections or CERNs, can contain shock waves in compressed magnetic fields, causing stormy space weather. These regions can appear or alike, and can cause significant damage to the Earth's magnetic field. A crack occurred on July 7th, causing a long-lasting G1 class geomagnetic storm. The National Oceanic and Atmospheric Administration (NOAA) has reported that a coronal mass ejection was embedded in the solar wind. So should we be worried about the possible impacts of this crack? Well, experts say, worry not. These cracks in the Earth's magnetic are normal and are there to protect us from solar storms. These cracks are said to be open for hours, and no amount of radio blackouts or power outages were reported due to a crack opening in the Earth's magnetic field. Normally, after a few years of operating, particle physics experiments usually suffer from diminishing results. So, in order to address this problem, the Large Hadron Collider has begun upgrading the devices, especially those related to collision energy, luminosity, revealing the laws of nature at incredibly short distances. Bunches of protons collide 40 million times per second in the LHC, with each collision having at least 50 or more individual collisions. The photographic evidence of these collisions is captured by major LHC detectors ATLAS and CMS, which write permanent storage. The LHC experiments generate a vast amount of data, and the trigger system selects a few hundred collisions per second for analysis. The LHC experiment already constitutes one of the largest computed databases in the world. Some of these newly proposed particles could be heavy and decay into clusters of quarks and leptons. There is a real opportunity in searches for weakly coupled new particles like those predicted in models of dark matter. These particles tend to have low rates, but any increase in the data set could prove helpful. The future circular collider, the most powerful particle smasher ever built, is expected to cost between 9 and 21 billion euros. However, some argue that the large sums involved could be better spent on other large facilities, such as placing a major radio telescope on the far side of the Moon or a gravitational wave detector in orbit. Despite the slow progress of the LHC, it is providing access to deeply buried knowledge that was unattainable previously. The construction of a circular collider, estimated to cost between 9 and 21 billion euros, is a controversial topic. The Frankfurt Institute of Advanced Studies theoretical physicist Sabine Hosenfelder believes there is no need for new physics in the energy regime for such a collider to reach. Instead, the large sums could be better spent on other large facilities, such as a radio telescope on the Moon or a gravitational wave detector in orbit. Run 3 is expected to bring forth several surprises, such as the recent crack in Earth's magnetic field that remained open for several hours. The LHC is expected to continue running, and accumulating data for future discoveries, with plans for a future circular collider under consideration. As we conclude the video, we are left in awe of the continuous progress in scientific study and the unexpected phenomena. The crack in the magnetic field of Earth is just a glimpse of the mysteries unfolding around us. Thank you for joining us, and until the next time, keep exploring the wonders of our universe.